last page. So it says sometimes we've seen crazy fractions within fractions. So these are called complex fractions. Now it's not called complex fractions because they're complex numbers, so it doesn't have i's in them. They're just complex fractions because they look really difficult. Okay, so it says a complex fraction contains one or more fractions in its numerator, denominator, or both. So try simplifying the complex fraction 1/2 over 3/5. So when we had 1/2 divided by 3/5, so back when you were first learning fractions, we always wrote it as 1/2 divided by 3/5. So I've told you guys before, William Fung found out what that's called for me. It's called an obolus. Okay, I always called it the old school division sign. So this obolus is this dividing sign, and when I see it, I know that it's the same as 1/2 times 5/3. You can multiply by the reciprocal. So it's convenient to write it with that old school division sign so you can see that. So now when I do that, I get 5 over 6. So just multiply across the top, multiply across the bottom. That's your answer. Okay, so let's do the same thing with these polynomials. So it looks scary. That's why they're called complex fractions, but it's really not. So you just divide by x minus 3 over x plus 5. So now when we see it written in that form, like divided by the fraction, I know it's times that reciprocal of the second fraction. Okay, so when I multiply x plus 2 times x plus 5, and then I'm going to multiply x minus 1 times x minus 3. So nothing canceled. A lot of times things will, but in this one it doesn't. So I'm going to FOIL. So when I FOIL, I get x times x is x squared. My outer is 5x, my inner is 2x, so plus 7x. My last terms, 2 times 5, make 10. All over first is x squared. Outer is negative 3x, inner is negative 1x, and minus 4x. Negative 1 times negative 3 is plus 3. So that's your answer. You can write it in either form. You can write it in the factored out form or in the FOILed out form. It doesn't matter. All right, now let's look at this next one. Okay, this next one's a little scary because you have 3 over x plus x over 2, and then divided by x minus 1 over x. So we don't have like a fraction divided by another fraction. So any ideas? Anybody know what to do at the top? So Anne, what do you think?
Get the least common denominator.
So get common denominators, yep. With these two. So that means that I'm going to have to multiply 3 over x by 2 over 2. So that way the bottom becomes 2x. And if I want the other one to become 2x, I need to multiply it by x over x. Okay, and that's allowed because you're just multiplying each fraction by 1. You're not changing the number. Okay, so when I do that, I have 2 times 3 is 6, so I get 6 over 2x plus x squared over 2x all over x minus 1 over x, which since we got those common denominators, that allows us to combine them into 1. So it's 6 plus x squared over 2x, all divided by x minus 1 over x. Okay, now that you see it in that form, that allows you to use that little obelisk sign. So you're going to say 6 plus x squared over 2x divided by x minus 1 over x. If you skip that step, it's fine if you can see it. So it's going to be 6 plus x squared over 2x times the reciprocal, so times x over x minus 1. Okay, on this one, not much cancels. So the x and the x cancel, but that's it. So on the top, you get 6 plus x squared all over 2 times x minus 1. So I'm going to actually multiply that in, so 2x minus 2. Okay, and that's it. Okay, I do want to show you one shortcut for that. So do you guys see all that? Here's your shortcut. I'm going to write it up here in this corner because it's very short. Okay, so if you have 3 over x plus x over 2, all divided by x minus 1 over x. My pen's not working very well. All right. Use the common denominator thing that we were talking about. But think about the common denominator for all of your denominators. What would the common denominator for x2 and x be? Just 2x, right? You're going to multiply this whole top by 2x and the whole bottom by 2x. And that doesn't change your fraction because you've now multiplied by 2x on top, 2x on bottom, so it's like you're multiplying by 1. Same kind of idea. So now when I multiply by 2x, so 2x times 3 over x, your x's would cancel, right? So you'd get 6. And then when I'm distributing the 2x in, so 2x times x over 2, what cancels there? The 2's. So you get x times x, which is x squared. All over, multiply 2x by the bottom. The x's cancel, so I'm left with 2 and x minus 1. So that's how you get the 2x minus 2. Okay, much easier, 2 steps. Okay, so I like that way personally, but if you don't understand that way, you can always do the first way that we talked about. Okay, so that's the end of our notes. Oh gosh, there's still a challenge problem? Are you lying? This is a long section. Oh man. Yeah, this is a hard one. All right, I'll let you guys take your break first. All right, so this last one, it says challenge. A hiker averages 1.4 miles per hour when walking downhill and 0.8 miles per hour on the return trip when walking uphill. What is the hiker's average speed for the entire trip around to the nearest 10? All right, it says, note, this type of question is always asked on standardized tests. The key to solving it is find the total distance and total time, then divide to get the average speed. All right, so they aren't usually this hard on the standardized test. This is a true challenge problem. It's something that I would possibly put as a bonus on your test. But, you know, it kind of gives you the idea. Basically, on the SATs, you're going to get something like this, where it's going to say 1.4 miles per hour, 0.8 miles per hour, and it's going to say, what's the average speed? And most people will add those together, so get 2.2, and divide by 2. So their answer is 1.1. All right, that answer is not correct. So it's not just averaging those two numbers. So if you see that on the SAT, immediately cross that one out. It's not going to be that one. They're trying to trick you. The reason is because it took longer uphill than it took going downhill. If they were equal times, then yeah, you could divide them out. But they aren't equal times. All right, so on this one, we don't know how long the trail is. So we're going to say let D equal the length of the trail or distance. So that's just one way. Okay, so always when you're trying to find the average speed, it's always the total distance divided by the total time. Okay, do you guys know that equation, like distance equals rate times time? That's where it's coming from. Divide your t over d over t equals r. That's where that's coming from. All right, so total distance. So that's adding the distance uphill and adding the distance downhill. Well, both of them are d, so it's just going to be d plus d. But then total time, that's harder. So whenever I'm solving for time, if you look back up at this equation, time is distance divided by rate. So going uphill, your time is distance, which was d, divided by your rate. So going uphill was 0.8 miles per hour. But then going downhill, your time was the distance divided by your rate, so 1.4. Okay, those are your two times. So your total time is just adding the two together. So it's going to be distance divided by 0.8 plus distance divided by 1.4. So on the SATs, what they usually do is they give you some kind of distance. Like they'll say, oh, the length of the trail is 4 miles. So it's easy to find. You just do 4 miles divided by 0.8 to find the total time that they traveled. So it's a lot easier on the SATs. But it actually doesn't matter what the distance is. Because if I'm going, you know, for 4 miles at a certain rate, and then I'm going 4 miles back at another rate, my average speed is still the same if I was going like 1 mile there, 1 mile back. So it actually works out to be the same, so you'll see why. All right, so we need to figure out how to solve this. So I have 2d over d over 0.8 plus d over 1.4. So let's multiply the first one by 1.4 over 1.4. So I'm going to get common denominators. And multiply the second one by 0.8 over 0.8. Okay, so I have 1.4d plus 0.8d, and then they're both going to be over the same denominator. So someone do 1.4 times 0.8 for me. Daniel, you on it? 1.12. All right, so this means I have 2d divided by, so when you combine these two things, you get 2.2. So divided by 2.2d over 1.12, which is 2d times 1.12 over 2.2d. So this is why it doesn't matter how long it was. So on the SATs, it might say 4 miles, but then this distance cancels out anyway. So it doesn't even matter how long the trail was. So I have 2 times 1.12 divided by 2.2. Okay, Daniel, you on that one?
What?
Can you do that? 2 times 1.12 and then divide by 2.2. 1.0 what?
Yeah.
Is it not
Oh,
O? Just trying to remember from yesterday.
2 times 1.12.
Yep, 2 times 1.12
Divided by 2?
divided by 2.2.
2.24 divided by 2.
1.018.
Yeah, so 1.018. It goes on. I think it's a repeating. So that's your average speed, so that's in miles per hour. Okay, so it's not what you would think. It's not the 1.1 that we would think it was. It's that. Okay, does it make sense? All right.